Dear students, I welcome you for the today's lecture related to classification of pressure vessels in the subject of chemical equipment design. Now these pressure vessels, its classification is not specifically defined. However, it can be classified as the geometric shape based on uniformity of shape, that is the installation method, then presence of internals, then the pressure bearing situation, then wall thickness, then technological processes, or you can also call it as the functioning, that is nothing but your reactor, heat exchanger. That is one classification can be done based on the operating temperature, that is whether it's a low temperature, moderate temperature, or a high temperature, or a very high temperature. Similarly, based on the design pressure, low, under vacuum, moderate pressure, high pressure, and under a very high pressure. Also, it can be classified based on manufacturing method, how that vessel is fabricated, that is whether it is casted, forged, or by simple cutting and welding, bending and welding, that method, or have it used with a certain special method which can be applied for your high pressure vessels. Then you can also have the manufacturing material of construction, then usage mode, whether it's a batch process or continuous process, and finally on the end construction, whether it is open-ended or whether it is closed one. So one by one we will go into the details of this classification of vessel based on geometric shape, uniformity, installation method, presence of internal, pressure bearing situation, wall thickness, technological processes or functioning, operating temperature and pressure, manufacturing method, manufacturing material, mode of usage, and end construction. So first is based on geometric shape. Theoretically speaking, one can fabricate any shape, that is whether it can be a sphere, cylinder, cube, rectangle, square, cone, trapezoid, or kettle type, whatever the shape you can think or you can imagine, that you can fabricate. But is that fabrication process a simple one, or is it a complicated one? If I will fabricate a complicated shape, can I get certain advantage if I am investing more amount of the money for fabrication of those shapes? So looking at all these parameters, the generally used, that is the spherical shape, cylindrical shape, square shape, and cone are most commonly used. Out of that, cylindrical is the preferred one. Very simple to fabricate, very simple to uh, operate and handle. Then complicated shapes have difficulty in analysis, how the stresses will behave, then how the reactor fluid that is going to behave, which fluid dynamics that shape can have. Then the economic considerations in fabrication of complicated shapes. So considering all these factors, preferably it's the sphere, cylinder, square, or cone shape, or the combination of that can be used. So these are your spherical vessels, which are the most commonly used for your LPG storage or ammonia storage, where the pressure requirements are there, uniformity of the pressure that is will be there. This type of the vessel is preferred for storage of the high pressure fluids. High pressure fluids. You are converting LPG into the fluid state, liquefied petroleum gas. A sphere is very strong structure. It is the most strong structure. that is the spherical shape, gives twice the strength of cylindrical pressure vessel with the same thickness. That means if I am going to have the say 5 mm cylindrical 5 mm thickness cylindrical vessel and 5 mm thickness spherical vessel, this 5 mm thickness spherical vessel will be accommodating twice the pressure in comparison with the 5 mm thickness cylindrical pressure vessel. So by mathematically and formula wise we will study that in details. Nanta, it minimizes the material and maximizes the strength because it can withstand the higher pressure. So maximum strength it can have and the minimum material you can use it. Then even distribution of the stresses, which is most essential in the analysis of the material. So these spherical vessels, the stresses are uniformly distributed both internally and externally, and generally means that there are no weak points. No weak points because the uniformity in shapes that is there. If the non-uniformity in the shapes will be observed, then the concentration of stresses in a certain non-uniform parts, that will be more difficult for analysis. Any advantages of spherical storage vessel is that they have a small surface area per unit volume. Area per unit volume, that is meter square per meter cube. Area per unit volume, that is the meter square area, surface area per unit volume, that is nothing but your meter cube, that is meter square per meter cube. For any other shape of the vessel, they are having the higher surface area per unit volume. So this can be used for liquid ammonia or petroleum products and are usually stored in spherical vessels. They are also called as the Horton spheres. In industry, the term Horton sphere also is very common. So these spheres have more strength, distributes the pressure uniformly, don't have the corners to accumulate the pressure or accumulate the stresses, resist both tensile and axial stresses. Then strength comes from the unique geometry and the curvature. So these are the advantages of the spherical vessel. Now coming to the cylindrical vessel, which are the most commonly used in the industry. They are very easy for fabrication. Ease of fabrication, that is for any sheet which is available, a metal sheet if it is available, it can be very easily given the bend and can be obtained a cylindrical shape. In this, you are going to do the welding in the innermost outer section of the joint. So this part you can do the welding. So it is very easy for fabrication from the simple sheets. Minimum cutting, minimum wastages of the material that will be observed in this cylindrical vessel. So these are the most widely used pressure vessels and easy for fabrication. So fabrication cost that is also low. However, the cylinders are not as strong as the spheres, will have the half the strength as that of the sphere. So this weakness is reduced by the hemispherical or rounded ends being fitted. So whatever the sphere that will be cylinder that will be provided, I am going to attach a hemispherical or a toruspherical or a elliptical shape end curvature, that is called a head. So this head that is going to give you the uniformity in the vessel, which will help to reduce the stresses. This weakness is reduced by the hemispherical or rounded ends being fitted. If the whole cylinder is manufactured from twice the thicker material than compatible spherical vessel, so of similar capacity, storage pressure can be similar to that of the sphere. Twice the thickness of a cylinder will be equals to the thickness of the sphere. So most pressure vessels are cylindrical with 2:1 semi-elliptical head or the toruspherical head, or sometimes the hemispherical head also, and end caps on each end, that is the smaller pressure vessels, are assembled from a pipe and two covers. Then the disadvantages of these vessels is that the greater diameters are more expensive. As you are going to increase the diameter, then its bending cost, that also increases. Even as you increase the thickness, you will require the huge machineries to bend the thick metal sheets. So the huge dimensions of these machineries, that increases the fabrication cost for this cylindrical vessel when you are increasing the thickness and increasing the diameter. Generally, these are used for your reaction vessels, distillation towers, heat exchangers, and whatnot. Almost all your chemical equipments, they uses these cylindrical shaped vessels. Now the rectangular vessels. These are also common when you talk about the refrigerators. We have not seen the refrigerators in a cylindrical shape. We are mostly observing these refrigerators in a rectangular or square shapes. Even in our laboratory furnaces or laboratory ovens or heaters, they are also rectangular or square in shape. So that is the area where still the rectangular vessels, they are preferred. Rectangular vessels, they are also easy for fabrication. Only the cutting and welding requirements are there. There is no bending which can be which is bending is not preferred in case of your rectangular vessels. So fabrication of this rectangular vessels, that is even more easy. This type of the pressure vessels do exist, but it is very rarely found in the industries, not in the household purposes or not in the laboratory purposes. However, some rectangular box furnaces, they have been used in older days also. So, but nowadays nobody uses this rectangular box furnaces. So they are often used as bulk storage containers, storage vessels, or as baths in the treatment of metals and fibers and surface coating processes, etc. That means you are having a rectangular bath or rectangular tanks for the treatment. These are mostly the open tanks they are used, and in case of fiber, the fiber passes through these open tanks, or in case of your metal, before painting, it passes through certain treatment of pre-treatment of corrosion resistant layers, deposition of corrosion resistant layers. For that purpose, these open tanks, they are used. So these open tanks, then rectangular box furnaces, refrigerators, dryers, and the laboratory heaters, ovens, and furnaces, they are preferred with these rectangular shapes. Then the conical vessels. The conical shapes are used for the bottom attachments generally, because when you are using this bottom with a conical shape, it is easy for the material to flow. It is easy for the material to flow. So if you think of this conical shape, the material can easily flow downward direction and it can be taken out from this bottom very easily. If it's a rectangular in shape, flat in shape, then it becomes difficult for the material to take out from the bottom. So either I have to give a certain curvature or I can have a conical shape so that the material flow that can be very easy. So that is the advantage with this conical vessels. These conical shapes are used for bottom attachments. Generally, they are for the storage tanks, or that is called the silos, solid storage tanks. This is called the silos, bottoms of the silo. Now, if you will see in this figure, you can observe the bottom section of this reactor as the conical section, because this can be used for the solid flow, solid catalyst that will be there. That is your catalytic reactor. It's a huge one. The catalyst that should be very easy to flow in the downward for regeneration and reactor catalytic fluidized cracker, so that the conical shape that will be preferred for this one. Then combined vessels. Now looking at this figure, you can see the dimensions, the diameter of this vessel, the upper section with a higher diameter and the lower section with a less diameter, and the bottommost section with a conical shape. So three different dimensions are considered, even though such complicated shapes are difficult for fabrication, as well as the cost involvements are higher. But this is the process requirement, because in this upper section where the diameter is high, the load, the gas, liquid or solid load, that is the fluid handled load, amount of the fluid handled, that will be the more in this section, upper section. And in the lower section, comparatively the fluid handled will be less, quantity of fluid handled, the flow rates of fluid handled, that are less, and as a result we are trying to minimize the dimensions. Not only that, the velocities, the superficial velocities, that can also be adjusted based on these diameters. Now, if I am the same flow rate, say 10 meter cube per second is the flow rate, and now if it is passing through a higher diameter vessel, upper section, its velocity will be low, and if it is passing through a smaller diameter vessel, its velocity will be the high. Same amount of flow rate, as I am going to change the diameters, the velocity is going to drastically change. Theoretically, you will study this in your fluid mechanics. So that is the requirement of a combined vessel, where the load, velocities that can be manipulated by changing the dimensions or the shapes. The vessels can be made of various combinations of geometrical shapes. They are used rarely and are difficult to manufacture. Complexity in manufacturing. So non-uniformity in the shape is generated because of different geometries and having the specific reasons also. These are used where two different operations are carried in a single vessel. That is also one permutation and combination. That is two different operations that is carried out in a single vessel. If you think of a reactive distillation, that is the reactive distillation, at the bottom the round shape vessel that will be available, and where you can have the reaction that will be carried out. In the bottom section, the reactor, and in the upper section, there will be a distillation column, and that is why it's a reactive distillation. Both the operations, they are carried out in a single vessel, but with the different geometries. The purpose of these different geometries, at the bottommost section you will having the reaction, and as the reaction progresses, whatever the fluid that is generated, it will be taken out, and the purification of that can be obtained, pure product can be obtained. So it's a reactive distillation. Then silo with the square at upper section and the conical at the bottom section. That is mostly it's silos or the solid storage vessels. They are having the conical bottom section for the easy flow of the solids. If the chips, polymeric chips are there, then at the bottom, the cone section or the solid handling, solid powder handling, you will require for the easy flow. The silos with the square at upper section and the conical at the bottom section for ease of removing the solids. If the fluid holdups are different in different sections of the column, that is the another reason, and the velocity adjustment, that is also one of the reasons. So based now the second, these are the all shapes. Now whether the shape is uniform or non-uniform, based on that one can also classify, that is the uniform shape pressure vessels and non-uniform shape pressure vessels, that is the combinations of that. That can be also one of the classification. Uniform shape pressure vessel is a single geometrical shaped vessel with a fixed diameter, and non-uniform shape pressure vessel, that is the geometry of the vessel is same, but the dimensions may vary at different height. So the single vessel is constructed with a different shell diameters of various height, that we have already seen in this figure, that is the non-uniform shape pressure vessels. Usually the vertical cylindrical vessels are constructed with different diameters, resulting in the non-uniformity in shape. That is your distillation column, vacuum columns, gas liquid loads are different. There is non-uniformity in the shape vessels, they are accepted. Then the third category, that is based on installation method. How that vessel that is installed, whether it is a vertical installation, horizontal installation, or sometimes the inclined installation. If you will say the certain dryers, that is also the inclined one, rotary dryers. There you can see the inclined one, but mostly it is the vertical vessels or the horizontal vessels. Now vertical vessels which are vertically oriented under uh, this category, they are with the specific diameter and are moderately tall. For example, the towers that is 3 feet in diameter and 150 feet tall. So this is if you will try to adjust it in a horizontal way, then it will take a huge space. So it is easy to increase the height as compared to increase the diameter. And in case of your distillation columns or absorption columns, where the process itself talks about that there should not be the horizontal uh, increase in the diameter, because the loads are less, and in every step of a distillation column the purification increases, and that is why we are putting the number of plates or increasing the number of plates for the purification of product. Then the heights of 2 meter or say 100 meters. Okay, These vertical vessels are preferred when the fluids are to be distributed across the small cross section. This is the basic requirement. We are trying to minimize the diameter so that the fluid will be uniformly distributed. No channeling or less channeling, minimum channeling will be there. That is what the requirement of uniform distribution, because everywhere there is a contact between the gas and the liquid. Sorry. There is a small liquid load, smaller or limited plot space is available, that is the area limitations. Cost of the land, that is also important. Then the ease of level control is desired. For a large diameter tanks with a smaller height, when the change in the level is small, it is very difficult to manipulate with those levels. If it's a tall vessel, then you can properly note down the changes in the level also. So these are your different vertical vessels. You can see these are your vertical vessels. Then the horizontal vessels, your horizontal vessels, their orientation is only horizontal, but they are mostly the cylindrical vessels are there. But these vessels which are horizontally oriented come under this category. These horizontal vessels are preferred for large liquid loads are involved. The quantity of the liquid handled will be the large, because we have to handle the large quantity. If I'm handling the large quantity and if I will increase the height, then the volume will be the same for any tank, but the head will be more. The liquid head will be the more if I'm using the vertical tank. So statistic pressure head, that will be the more liquid head. Then the large liquid loads are involved, consequently the hold up will set the size. Then three phases are present, that is the solid phase that is present. Then these horizontal vessels, they are preferred. Again the weight which is available in the vessel. The reason for using the horizontal vessel to promote the phase separation is one of the phases separation, that is the solid and liquid separations are there. In those cases, the horizontal vessels, they are preferred. Diameters are increased, there the velocity that is reduced. As the velocity that is reduced, the solids will be settling at a faster rate, and that is why this big diameter or the horizontal vessels, they are promoted in case of your phase separations, solid separations. That is increased cross section, it lowers the vertical velocity, less entrainment that will be available or associated with these horizontal vessels, to allow the internals to be pulled for cleaning purposes in case of your heat exchangers. It is you have to remove the tube bundle from the heat exchanger for cleaning purpose. At that time, the horizontal vessels, they are uh, preferred. Horizontal shells or orientation of these heat exchangers in a horizontal way, that will be the preferred one. The different vessels, that is your decanters, settling tanks, separators, flash vessels, they can be used in a horizontal direction. Now next is the based on the presence of internals, that is without internals and with internals. Without internals, they are only the drums or tanks, but maximum vessels, they are with a certain purpose, and that is why they are with certain internals. whether it's a reactor, distillation column, absorber, heat exchanger, everywhere there is some or the other internals. Only for the storage tanks and the drums, there are no internals. Now, what is the distinction between the drums and the tanks? That is simply a dimensional difference. But when you talk this dimensional difference, it is not specifically defined still now. Even in case of our household drum, when you talk, the drum can be of say 50-liter drum to 200 liters drum, which we can say in which we can see in our day-to-day life. But when you go into the industries, these drums they can be also of diameter of 1 meter or 2 meter or even 3 meter diameter with a height of 5 meters to 10 meters. That they are also called as the drums. But the purpose of the drum is that is for a temporary storage. For tanks, when you call, it's a storage based on the uh, 1 day or 1 week. When you talk for a drum, the fluid comes into the drum, that is your flash drum. Fluid comes and instantaneously it leaves the that vessel. So that terminology is preferred in the industries. The residence time of the fluid, process fluid in case of drums is less as compared to the tanks. In tanks, the holding time or the is more in comparison. The drums and the tanks are the vessels in chemical processing services that are without internals. No internals are there. The main function are to provide the intermediate storage. That is the basic purpose. Intermediate storage, surge of the process streams for a limited or extended period. Limited or a extended period, and to provide a phase separation by settling. That is also the phase separation. Flash drums. Flash drums, the vapors are coming and the flash is there because of the pressure difference. You will get the vapors from the top and the liquid from the bottom that will be separated out in these flash drums. The distinction, the size may be established by definite process calculations or the general rules or by experience. The distinction between these drums and the tanks is that of the size and not the shape. And this distinction is not specific. कि 2 मीटर के ऊपर का है, you are calling it a tank, or below that drum, it is not like that. It depends on its function. That is, main function is to provide the intermediate storage surge, whether it is for limited time or extended period. Then usually they are the cylindrical vessels with a flat or curved ends. Generally the flat end which we see in our day-to-day life, the drums they are of a flat end. But in case of the industries, they can be curved end also, depending on the process requirement. Then in a continuous plant, drums have a hold up of a few minutes. This point can be noted. Drums have the hold up of few minutes in a continuous plants. And that is why we call the flash drum. We doesn't call it a flash tank. We generally call it a flash drum, where the hold up or the residence time of the process fluid is only a few minutes or say few seconds, not in hours. They are located between the major equipments or supply feed or accumulate the different products. In case of your flash drums, the liquid that is getting accumulated and the vapors, they are of your more concerned. Then surge drums between the equipment provides a measure of stability. The pressure fluctuations, they can be adjusted and they are called as measure of stability, so that the fluctuations are not transmitted freely along the chain. So that before the reactor, there will be a surge drum where the whatever the vapors that will be there, they will be adjusted with a uniform pressure. प्रेशर रेगुलेशन का भी काम करता है. दैट इज व्हाट द सर्ज ड्रम्स आर. That is, the reflux drums provide the surge between a condenser and its towers and the downstream equipments. Your reflux drum, in case of your distillation column after the condenser, reflux drums will be there. The drum ahead of compressor will ensure the freedom from liquid entrainment. Also, in case of compressors, these drums that will be provided, so that whatever the uh, vapor or humidity, because of compression, your liquid will be getting separated. For that purpose, this liquid entrainment zones, they are also provided. Then the maximum shell length to diameter ratio for small vertical drum is 5:1. 5 is your length and 1 times is your diameter. Generally, the tanks are large vessels. These are large vessels and several hours of hold up. That is, the hold up is more in case of our tanks, and that is why they are called as the tanks where the hold up is more. For instance, the feed tank of a batch distillation may hold a day's supply, and rundown tanks between the equipment may provide the several hours hold up as the protection of the main storage from the possible off specification product and the opportunity for local repair and servicing without disturbing the entire process. So main thing is that for the tanks the hold up is more, and for the drums the hold up is of few minutes or few seconds. Now the vessels with the certain internals, and these are most common vessels. That is, with the internals, reactor hai, there you will have a agitator and a impeller that will be there. Distillation column, the distributors, tray, downcomer, weir, all these accessories will be there. In case of heat exchanger, there will be the tubes, tube bundle, tube sheet, baffles, all these internals will be there. So maximum vessels will have some or the other internal except for the tank and the drums. The most vessels have at least some or the other internals. Examples are your distillation trays, packing support, distribution grids, heating or cooling coils. Then welding of the inside of the vessel, all these accessories that is welded to the vessel itself. The shell of the equipment such as your heat exchangers, reactor, mixer, fractionator and other equipments, where the housing can be designed and constructed largely independently of whether the internals are necessary or not. It is what the housing. It is called a shell of a heat exchanger. That is called a housing. House for a tube bundle. So their major dimensions are established by the process requirement. The internals and support rings need to be considered when calculating the vessel weight and the stresses analysis. So you can see the different distributors in this vessel. The inlet distributor, then bottom outlet hub assembly distributor, this is the side outlet header assembly distributor, all these are the distributors. Then based on the pressure bearing situations, whether the internal pressure vessels and the external pressure vessel, that is the pressure, based on the pressure. So internal pressure and external pressure vessels. So internal pressure vessel, the inside, it is the pressure inside the vessel. When the pressure is maintained inside the vessel, it is called as the internal pressure vessel. And in these vessels, the pressure is maintained inside is larger than the outside pressure. That is the gauge pressure. Outside is your atmospheric pressure. You are putting a certain gauge on that vessel, and this gauge will indicate some or the other pressure. That is considered to be as the internal pressure, positive pressure. They are subdivided into low pressure vessels, medium pressure vessels, high pressure vessels, and ultra high pressure vessels based on the pressure from zero point 0.1 pascals to 1.6 megapascals. Low pressure for medium pressure vessels, it's 1.6 megapascals to 10 megapascals. Then for the high pressure vessels, from 10 megapascals to 100 megapascals, and for ultra high pressures it can be greater than 100 megapascals. So this pressure requirement that decides the category of the vessel, and accordingly you have to use the different formulas when you are designing for low pressure vessel, for medium pressure vessel, high pressure vessel, and ultra high pressure vessel. In the previous class, we have talked about the division 1, division 2, division 3 for the ASME BPV code, that is the American Society for Manufacturers. There, the boiler and pressure vessel code, that is we are taking the division 1 in this low pressure vessel, division 2 for the medium and high pressure vessel, and for ultra high pressure vessel you will require the specifically designed or the division 3. Then the external pressure vessels, that is the pressure inside the vessel is lower than the atmospheric pressure. That is the second consideration. Pressure inside the vessel is lower than the surrounding pressure or around that pressure or atmospheric pressure. Now here the two situations are there. If the higher pressure is maintained outside the vessel, that is the outside pressure is higher than the inside pressure. That is if I am having the certain reactor, and to this reactor the jacket that is provided. Now this is the case where the jacket pressure is higher, this pressure is more, and this pressure is less. So this is the external pressure. Surrounding pressure is more. It is the high pressure is maintained outside the vessel. That is the outside pressure is higher than the inside pressure. It is called as the external pressure. And the second situation, that is the outs in general the outside pressure is the atmospheric pressure, and it is operated under vacuum. The vessel that is operated under the vacuum, but here the surrounding pressure is atmospheric pressure. So surrounding pressure से कम है ये, and that is why it is called the external pressure. Because external pressure outside pressure, this surrounding pressure that is the outside pressure. So this is the uh, internal pressure as well as the external pressure vessels that will be there. The next is based on the wall thickness.